Expand in Taylor series the function fz equal to 1 by z about the point z equal to 2. Because we need to expand the function about this point, so we need the expansion in the powers of z minus 2. And secondly, also we need to find the radius of convergence for this. Let's start with the solution. We need the expansion in the powers of z minus 2. The function given is 1 by z. We can write further this as adding and subtracting 2, because we need z minus 2, so I am writing here minus 2 first and then plus 2 in the second place. We need to add and subtract 2. And now taking 2 common from this, let's keep this in a bracket. Taking 2 common from this, we have z minus 2 divided by 2 plus 1. So this is 1 divided by 2. Taking this to the numerator with the inverse. If you consider this your x, then what is the expansion for 1 plus x inverse? This is equal to 1 minus x plus x square minus x cube, the alternate signs to the infinity. So using this result, writing this further, this is equal to 1 divided by 2 expanding. We have 1 minus x, z minus 2 divided by 2, this is your x, plus z minus 2 divided by 2 whole square minus z minus 2 divided by 2 cube up to infinity. And now writing in the summation format, we can write this as the summation and going from 0 to infinity, and because of the alternate signs I am writing here minus 1 the power n. When you put n equal to 0, you get minus 1 the power 0, that is equal to 1, and multiply this with z minus 2 divided by 2 the power n. When n is 0 over here, we get again this to be as 1. For n equal to 1, we have minus 1 into z minus 2 divided by 2, that is the second term. Likewise so on. And now writing this as summation n going from 0 to infinity minus 1 the power n. I am taking this 2 in the denominator. This is 2 the power n plus 1, right? Now since fz is not analytic at z equal to 0, now because our function is 1 divided by z, so this function is not analytic at z equal to 0, because when taking z equal to 0, the denominator becomes 0 at z equal to 0, right? Which means the function is undefined. So this function is not analytic at z equal to 0. So writing this, since the function is not analytic, this is your first part. This is 1 divided by z, we have expanded fz, this is the first part. And now the second part, since the function is not analytic at z equal to 0, so the radius of convergence becomes, what is the radius of convergence? The definition for the radius of convergence: the series for fz around z0. Here we have, in this example, z0 is 2. Given by the Taylos theorem, converges uniformly to the value of fz provided mod of z minus z0 is less than the distance from the z0 to the nearest point. At what point fz is not analytic? At z equal to 0, right? Here the function is not analytic and we have expanded the function about z0 equal to 2. It means the radius of convergence is the distance between the points 2 and where the function is not analytic, 0. The distance between the points 2 and 0, that means we need to get the distance mod 2 minus 0. So the radius of convergence will be the distance between the points 2 and 0. So that is equal to 2. Thus the radius of convergence of the series is 2. Okay, thank you.